Hi everybody, my name is Ruby and I'm a student at Cal Poly. Today, along with my friend Keegan, I'm going to be leading you through an experiment, which I'm super excited about. But before we start, I wanted to talk about the word concentration. Now, when you hear the word concentration, you probably think of someone focusing really hard on a task or trying to finish something, which is totally what concentration means. But today we're going to be talking about a different definition of the word concentration. So I just wanted to put that on your radar before we start the experiment, kind of tuck that in your back pocket as we move along throughout the day. And Keegan's going to get us started with the experiment, so I'll see you guys later.
Hey everybody, my name's Keegan, and like Ruby, I'm also a student at Cal Poly, and today we're going to be doing a fun experiment together. So in this experiment, we're going to be learning about the comings and goings of substances in and out of cells. For this experiment, first we're going to need a model of a cell, and so we are going to be using an egg as our model of the cell. Now before we begin, let's start off with some quick observations. So why don't you all grab your notebooks and a pencil, and I want you guys to observe these three things about your egg. First, I want you to write down quickly, what does it look like? Color, texture, here, I'll hold it up. Just make some observations about the egg, about its appearance, its characteristics. Then next, I want you to write down whether or not you think it's possible to see the inside of this egg without breaking it open. And then lastly, I want you to observe what you think will happen when this egg is put into a vinegar solution. All right, I'll give you a couple of seconds to write down those observations. Feel free to pause the video if you need more time. Okay, so after you've made those observations, we'll jump right on into the experiment. If you guys would like, you can follow along. We just use normal kitchen supplies for this experiment. But if you prefer to watch, feel free to do that as well. But for those of you following along, all you'll need is some white vinegar, 2 eggs. I'm only using 1 egg just for the purpose of simplicity, and 1 bowl. So we're going to start off, and this first part of this experiment is just turning this egg into our cell model. So right now, obviously it looks like an egg. It doesn't look very much like a cell. But very soon we will see that it will turn into our cell model. So we're just going to take the egg, we're going to put it into our little bowl, and then we're just going to add some vinegar. Just enough so that it covers the egg all the way. All right, do we see? Perfect. And now all we have to do is sit back and wait 48 hours, and once we come back we will have our cell model. So for those of you following along, just cover it with some saran wrap and leave it in a place that is room temperature. And for those of you just watching along, I'll be vlogging daily to show you our progress on our little egg model. Okay, see you guys soon. Hey guys, so it has been 24 hours since we last put our egg into the vinegar, so let's check up on it. And I don't know if you guys can see, but there are some bubbles going on. It seems to be a little bit bigger. If you guys have any other observations, you can feel free to record them right now. Alright, and we're just going to wait another 24 hours, and soon this egg will be our little cell model. Alrighty folks, so it has now been 48 hours, and our egg has officially turned into our cell model. So I'm going to flip the camera around, and I want you guys to make some initial observations about what it looks like and how it is different from that egg that we first started off with. Alright, so here is our completed cell model, and as we can see, it looks pretty different than the original egg that we started out with. So first of all, I want you guys to make some observations in your notebook about the color, about the texture, and just overall how it looks different than the egg that we started out with. And feel free to pause the video to take some time to make those observations. And next, what we're going to do is because this is our cell model, we're going to identify important components of a cell and how they are represented by our cell model. So the three components that we're going to be focusing on are the membrane, the nucleus, and the cytoplasm. So what we're going to do next is we're going to make predictions on what parts of this cell model represent those three things: the membrane, the nucleus, and the cytoplasm of a real cell. So the first thing that we're going to observe, a key observation, is that the shell, obviously, of this egg is gone, but the egg is still held together by something. And this is something that is squishy and not like that original shell that was surrounding it. So what part of the cell do you think that represents? And then another thing that we're going to observe is, we can see it better in the water, but we can actually see the yolk itself, right there. And so what part of the cell do you think is represented by this yolk? And then the last part of our cell model is the stuff in between the outside of this and the yolk, all that substance in between. And then what part of the cell do you think that represents? Feel free to pause the video to make your predictions. All right, now let's clarify. So the outside of our cell model is like the membrane of a cell. It is a semi-permeable membrane, which means that substances such as water or vinegar can move in and out of the cell easily. It isn't like it's surrounded by a hard rock where it can't get through. It's a semi-permeable membrane, so it can get through. So that is the first part of our cell model. The second part is the yolk, and the yolk will represent the nucleus of the cell, and all the other liquid inside in between is going to represent the cytoplasm. So all the stuff in between is like the cytoplasm. And so now we have our cell model, and we know that it has these three parts. It has its semi-permeable membrane, it has its inner nucleus, which is represented by the yolk, and it has its cytoplasm, which is all the other stuff in between. Well, now that we have our cell model, we can now test how this cell will react when it's put in different substances. And because this membrane is semi-permeable, we're gonna see the movement of substances in and out of this cell model. And we're gonna see how that affects this cell model. So that part of the experiment is going to be covered by Ruby, so I'll let her take that away. Here's a different angle of our egg model. I just wanted to show you guys because you can really see the yolk very clearly. So this is an answer to one of our questions from the beginning, in that yes, we are able to see the inside of an egg, the yolk part of an egg, without actually breaking it open.
Hi everyone, it's nice to see you again. So now we're going to enter the second part of the experiment. So we have our cell model, and first what we're going to do is weigh it. My scale's at 0, so I can put it on the scale. This one weighs 3.1 ounces, and this is going to go into, they're both going to go into different liquids, and we're going to see how they react in those liquids. And then this one weighs 2.8 ounces. Okay, so the one that weighs 3.1 ounces is going to go into corn syrup. And the one that weighs 2.8 ounces is going to go into salt water. And we're just going to let these soak for a little bit, and I'll see you when we come back to see the results. I forgot to mention that if you only have one egg, that's totally fine. One cell model, that's totally fine. We can just put them in one of the substances, whichever one you want to choose, and we can just look at both of the results here together. So don't worry about it if you only have one. So while our cell models are soaking, I want us to write down some predictions of what we think will happen. So here are some questions to help you get started with those predictions. Do you think that corn syrup has a higher concentration or a lower concentration than the liquid inside of our egg? Do you think salt water has a higher or lower concentration than the liquid inside of our egg? And what do you think will happen to the cell models and / eggs in each of the concentrations? So jot down some ideas of what you think will happen, and we'll check back in a little bit. Okay, so these eggs have been sitting in salt water and corn syrup for about 2 hours now. And I don't know about you, but I am ready to see what happened. Okay, so first we're going to take the salt water, and before, when I weighed it, before having it soak, it was 2.8 grams. So let's see what it is now. This time, it is 3.1 grams. That's interesting. I wonder how that happened. And let's take this one in the corn syrup, which before letting it soak was 3.1 grams, and after is 2.7 grams. So we saw that the corn syrup made the egg get smaller, and the salt water made the egg get bigger. Can you see that? This one's quite a little bit bigger than this one. So I want you guys to write down some ideas of what you think happened, and Keegan is going to give us an explanation in just a little bit.
All right, everyone, we have reached the last part of our lesson, and so it's time to start wrapping things up. In this lesson so far, we made predictions about what we thought was going to happen, and then we did our experiment, and then we observed the things that happened as a result of our experiment. Now we are going to be exploring why we saw what we saw. And what did we see? Well, we saw that when we put our cell models in different solutions, they reacted in different ways. When we put our cell model into salt water, it grew bigger, and when we put our cell model in corn syrup, it grew smaller. Now we must answer the question, why did our cell models shrink, and why did they expand? Well, remember that whole concentration thing we talked about in the beginning? That is a big part of our answer to why the cells grew smaller and why they grew bigger. Concentration means the amount of substance in a particular amount of space. So here we have two different liquids with two different concentrations. The one on the left here is more concentrated because there are more molecules all packed together into one space. And the one on the right here is less concentrated because it does not have as many molecules in it. The more concentrated a solution is, the more thick it will be. It turns out that the corn syrup had a higher concentration than the egg, and the salt water had a lower concentration than the egg. Going back to these pictures, the corn syrup would be like this one on the left because it's more concentrated, more molecules all packed together, and the salt water would be this one on the right here. And this makes sense, right? Because when you think of corn syrup, you know that it is thicker and it is stickier and it moves around not quite as easily. But salt water, on the other hand, is not very thick. It is loose and it moves around very freely. So we know that the corn syrup had a higher concentration than our cell model, and the salt water had a lower concentration than our cell model. Why did the difference in concentration cause the cell model to shrink and to expand? What does concentration have to do with the size of our cell model? Well, remember when we said that the thin membrane around our egg, around our cell model, is like the cell membrane? Well, when we were talking about that, we discussed this term semi-permeable, and we talked about how it meant that certain liquids, like water, can pass through the cell membrane without breaking it. And these substances, such as water, that do pass through the cell membrane, they have to follow a rule, and this rule is called osmosis. Osmosis means that substances, when they are passing through a semi-permeable membrane, they must always move from areas where there is less of that substance to areas where there is more of that substance. In our experiment, water was the substance that was passing through the cell membrane, from the inside of our cell model to the outside, or from the outside of our cell model into the inside. Water molecules want to be equal, so the part that has a lower amount, the part that has a smaller amount of water molecules, will always want to move to the part where there are more water molecules. So if you have a higher concentration, like the corn syrup, there's less room for water molecules. So we can see here that there's more solute molecules in here, which we'll talk about in a second, which means there's less room for water molecules. So there's going to be a lower amount of water in this corn syrup solution. And on the other hand, we see here that there is less other solute molecules here, and so therefore there is more room for water. Another way of describing osmosis is to say that water will always move towards the higher solute concentration. Now, solute just means any type of molecule, such as salt or sugar. And when we think of the corn syrup, we know that it had lots and lots of sugar molecules in it, all packed together, which means that it had a higher solute concentration, which means that it had less room for water. So the water that was inside of the egg wanted to move out to the area of higher solute concentration, where there was less water. Now let's look at some drawings, because I know for me it helps me to see what's going on instead of just hearing about it. One of our cell models was put into corn syrup. Now, corn syrup, we know, has a higher solute concentration than the solute concentration inside of the egg. This means that there's less room for the water in the corn syrup. And so there is less water in the corn syrup than there is in the egg. And because water follows the rule of osmosis, it moves out of the egg and into the solution, to the area where there's less water, right? It wants to be equal. It wants to balance itself out. And so what do you think happened when the water left the egg? What happens when one thing leaves something else? What happens to that something else? That's right, it shrinks a little bit. And that is exactly what we saw happen when we put our cell model into the corn syrup. We saw it grow smaller. Now, our second cell model was put into salt water. Salt water has a lower solute concentration than the solute concentration inside of the egg. This means that there's lots and lots of room for water in the salt water. So there's way more water on the outside of the egg than on the inside of the egg. And following the rule of osmosis, water moves to where there's less of it. So it moved from the saltwater solution and into the cell model. And when water is added to something, it grows bigger. And that is exactly what we saw happen. Our cell model expanded after it was put into the salt water. So to summarize, the whole reason that our egg cell models shrunk and expanded was because of osmosis. And remember, in this experiment, we are using an egg to demonstrate the characteristics of cells. So obviously we weren't experimenting with real cells, we were just using an egg as our model to be able to see what happens to cells when different substances move in and out of it. So this does happen in real life, right? We do have cells in our body, and the cells of our own bodies behave in the way that we just observed. Cells do shrink and expand in our bodies based on the concentration of the liquid surrounding them. Alright, that is all we have for you today in this lesson. We hope you enjoyed it. I know we really did. Thank you for being such great listeners, and thank you for following along with us as we explore cells and how substances move in and out of them. Have a great rest of your week and have a fabulous summer.